student. I am Dr. Anamika Goyal, Assistant Professor at ABES Engineering College, Ghaziabad. Today I am going to discuss about the next topic of Unit 5th of the subject Design and Analysis of Algorithm, that is Randomized Algorithm. In this lecture, I am going to discuss about first what is randomized algorithm, why we require this. After that, we'll discuss the classifications of randomized algorithm. We can classify the randomized algorithm into two different categories. First one is the Monte Carlo algorithm. We'll explain this algorithm with the help of suitable example. After that, the next algorithm is Las Vegas algorithm. We also explain this approach with the help of suitable example. So let's start our topic. What is randomized algorithm? A randomized algorithm, it is an algorithm that employ a degree of randomness as a part of its logic. Here you can see randomized. So basically in that algorithm, we use a random number to decide what to do next anywhere in its logic, that is called randomized algorithm. Randomized algorithm, it's a concept which is basically used to improve the time complexity and space complexity of an existing algorithm. Right? Randomized algorithm, it is also known as deterministic algorithm. So what is the concept of deterministic algorithm? In deterministic algorithm, we have a definite path to find out the output of a given input variable. So in case of deterministic algorithm, what we have to do in deterministic algorithm, we have some input. On the basis of their input, we apply some deterministic algorithm or process and generate output. In the case of deterministic algorithm, our output will depend the size of input. This is called deterministic algorithm. Now our randomized algorithm is also known as randomized algorithm. It is also known as dot deterministic algorithm because in that case we use the process deterministic algorithm, but here we use another concept is random number. We add a one concept random number here. Then for certain input, it will produce output. In case of randomized algorithm, we apply deterministic algorithm with the uses of random number and then produce our output. So in that case, our output will depend the random number and the size of input both. So this is the concept of randomized algorithm. Randomized algorithm classify into two different categories. First one is the Monte Carlo algorithm. Second one is the Las Vegas algorithm. Monte Carlo algorithm are those algorithms whose output may be incorrect. For example, randomized searching algorithm. And Las Vegas algorithm are those algorithms whose output is always correct, like randomized quicksort. So to understand the concept of Monte Carlo algorithm and Las Vegas algorithm, first we'll discuss Monte Carlo with the help of randomized searching algorithm, and after that we'll discuss Las Vegas with the help of randomized quicksort algorithm. So first we'll discuss Monte Carlo algorithm with the help of example. Suppose first we'll discuss linear search algorithm. In case of linear search, we are just giving a list of element. We are just giving a list of element. Suppose we are just given an array A whose element are 2, 8, 10, 3. And we have to find a key value A whose value is 10. We just check this 10 is available in this list or not. In case of linear search, we'll start our loop with index value 0 to till n minus 1. It means 0 to 3. So, first we'll check A of I means A of 0. If A of 0 is equals to A, 2 is equals to 10. No, 2 is not equals to 10. Then we'll increment the value of I by 1. Then we'll compare A of I means 8 is equals to 10. No, it is not equals to 10. Again, we'll increment the value of I by 1. So again, A of 2, it means 10 is equals to 10. Yes. Our item will available or our key value will available at second locations of is an array. This is called linear search algorithm. It will take order of n time for computation. Suppose in the list we have n number of elements, so it will take order of n time to find the key value into a given list of elements. Now we'll discuss Monte Carlo search algorithm. In case of Monte Carlo search algorithm, again we take same example. We are just given an array for four element A, 2, 8, 10, 3, and the index value 0, 1, 2, 3, and the item or key value that is 10. This key value will search using Monte Carlo search algorithm in this array. So again we'll start 0 positions to 4 positions. First we'll generate I random using random function. For example, it will generate index value 3. So 3 mod n. Mod is 4. 3 mod 4. 3 mod 4 is 1. In case we'll divide 3 to 4 and store the remainder value. Right? 3 mod 4. So remainder is 3. Sorry, remainder is 3. 3 mod 4 plus 1. It will give 4. It will give 4. 3 mod 4. It will produce 4. Again, will generate another number. For example, 1. I will generate, this will not present in the list. Then again will produce I random number. It may be 1. So 1 mod 4, whose output is, again will divide 1 on 4 and the output is 1. 1 plus 1 is 2. So I is 2. Now we'll check if A of I. If A of 2 is equals to A of 2 is 10. 10 is equals to 10. Yes, our key value match at ith location, second location. So this will take order of one time for computation. If the key value is available in the list, we'll find it order of one time. If it is not available, then it will return 0. Here you can see, for example, it will generate 2, then 2 mod 4 is 2. 2 plus 1 is 3, A of 3. If the value of I is 2, so in that case, 2 mod 4 1 is equals to 3. A of 3 is equals to A. In that case, A of 3 is not equals to A. So it will return false. This is the wrong output. So that's why we'll say Monte Carlo algorithm not ensure the right output. This is the concept of Monte Carlo randomized algorithm. I hope you understand the concept. Now we'll discuss our next classifications of randomized algorithm, that is Las Vegas randomized algorithm. Randomized algorithm will produce or will ensure the correct output. So to understand the Las Vegas concept, we just take an example of randomized quicksort. Now if I am talking about normal quicksort algorithm, so what we have to do in quicksort algorithm? In quicksort algorithm, basically we just find the pivot value of an element. Pivot value, we can select pivot value as the first index value of an element, or we also select the pivot value as the last element of an array. Then what we have to do, we just call the partition function, and the partition function, after calling the partition function, our pivot value come into the right position. The lesser value of pivot element comes in the left hand side of an array, and the greater value of pivot element come in the right hand side of an array. So after the partition function, our array is come in come in a proper sequence. Lesser value in left side, pivot value, the value which is less in pivot value will come in left hand side, and the value which is greater than the pivot value come in right hand side. So this is basically the concept of normal quicksort algorithm. In case of quicksort algorithm, if the list of element in an array is already sorted, so it will take order of n square time. So to reduce this time complexity, we use randomized quicksort concept. To understand the randomized quicksort concept, let us take an example. Suppose we are just giving an array A whose value is 10, 20, 30, 40 and 50. Array index 0, 1, 2, 3 and 4. In that case, what we have to do, 0 represent the starting index of an array P and 4 represent the ending index of an array R. So first we'll check if 0 is less than equals to 4. The condition is true. Then what we have to do, we just call randomized partition here, not call normal partition. We just call randomized partition. So our call comes here. In case of randomized partition algorithm, I will generate using random functions. Suppose the value of I here is 2. Suppose it random function will generate the index value I is 2. So what we have to do, we just exchange A of R to A of I. It means our output array is just like that. Our output array is just like that. A of 2 is 30, then 10, then 20, then 40 and then 50. This is 0, this is 1, this is 2, this is 3, this is 4. This is your array after swapping. Then we'll call normal partition function. And normal partition function we know in case of normal partition function we just select X, our first element as a pivot element. In case of normal quicksort partition algorithm, we just select X, our pivot element. Then what we have to do, we use two pointer for the comparison. In case we have choice, we choose X as a pivot element, or we also choose 50 as a pivot element. In that case, we compare if 30 is less than equals to 50. Yeah, 30 is less than equals to 50. No need to swap. Then we'll increment the value of I by 1. This is J pointer and this is I point. Now we'll increment the value I by 1. Then we'll compare 10 is less than equals to 50. Yes, no need to swap. Then again increment the value of I by 1. Then we'll compare 20 is less than equal to 50. Then again no need to swap. Then we'll compare 40 is less than 50. Then again no need to swap. After that, what happened? After that, 30 is less than 50, no need to swap. So after that, 30 is in right place, so no need to swap. So this is the partitions algorithm. After that, 30 will come. We just swap 30 to I plus 1 location. I plus 1 is here. So in that case, our outcome is, in that case, our output array after partition algorithm. After partitions algorithm, our pivot element come in its right place. Wait. After partition algorithm is same in normal quicksort algorithm. After partition algorithm, 10, 20, our pivot element come in their right position. Right? This is our pivot element come in their right position. The lesser value of pivot element come in left hand side and the greatest value of pivot element come in right hand side. So here you can see if the size of array is n. So if the size of array is n, so it will divide it into n by 2 equal partition. Generally, when we select the value of I using random number, generally the partition function will divide array into two equal halves. So again, if we consider n, so n will again divide it into n by 4 and n by 4. This n by 2 is again divided into n by 4 and n by 4. So in that case, our time complexity is order of log n. So in that case, our time complexity is order of n log n. So this is the basic advantage of randomized quicksort algorithm. If our array list is already sorted, so if we choose pivot element value using random function, so generally in general case, it will divide our array into two equal parts. N size array is n by 2, n by 2. Then again n by 2 size array is to n by 2, n by 4 and n by 4. Then n by 4 size array is n by 8 to n by 8. So the total time complexity in that case is order of log n. Running time complexity of our randomized quicksort algorithm is order of n log n. Sorry, it is order of Running time complexity of quicksort is not order of log n, it is order of n log n. So that's why we say randomized quicksort is better approach in comparison of normal quicksort algorithm. But here we have one issue. If the number of element in an array is same, like 5, 5, 5. Suppose we have an array of 3 element, 0, 1, 2. In that case, if I want to generate the value of I in random manner, so it will produce I is equals to 2. For example, it will generate I is equals to 2. So what we have to do, we just swap this 5 to this 5, right? But no change. This 5 here, this 5 here, again the output will be same. Again the output will be same. If we call random function, so what happened? This array will again same. So okay, what happened after the partition? This will 5, and after that this is 5, this is 5. This is the our output. So you can see here. So you can see here the partitions T of n in case when the all element of the array are same in randomized quicksort. So what happened? T of n is equals to T of n minus 1 plus one single element, right? It is one single element here. Then again we'll call T of n is equals to T of n minus 2 plus again 1 plus 1 into up to. So if I want to solve this recurrence relations using substitution method, so the time complexity is here is order of n. Order of n square. So we can say if I am talking about worst case time complexity of an array, worst case means if array is already in sorted manner, or we can say array is in reverse order. So the time complexity of randomized quicksort is order of n log n, and normal quicksort is order of n square. But here is only one case here in randomized quicksort. Here we have only one case where the all the element of an array are same. Then only randomized quicksort will take order of n square computation side. I hope you understand the randomized algorithm and its analysis. These are the references used in our presentations. Thank you.